Hello and welcome to Rick's RC Flying Channel. In this episode, we're going to take a look at some of the progress that has been made on the sweet and low fuselage. So as we're working on the engine fuel system setup, I just want to show you that inside this particular fuel bay, I epoxy resin the entire interior of this compartment. So it is very fuel proof. In the event, you have any kind of a leak ever, hopefully that never happens. Or, you could have a smoke oil line running through there, maybe, if it ever got disconnected or whatever. It's just an extra precaution. Since the fuel tank's in here, I always feel better if it's fuel proof. Not to mention that the epoxy resin does add some strength to it. It has a component of that. And, the little bit of weight that this adds, which is, again, it's forward of the CG. The fact that it's fuel proofed and adds a bit of strength to everything in there, I think is a good trade-off. So this is the fuel tank floor, which will get epoxied in there. So right now that's the way the fuel tank will sit nicely in there. And what I've also done is the engine motor mount system, which has 3 attachment points. So they were basically, properly located and orientated. It's kind of a funny thing. If you orientate this the wrong way, one of the bolts, you won't be able to get the socket driver to it. So anyway, something to bear in mind. And so I drilled that out and I put the line nuts in there, and they're epoxied. And so that's a good solid connection. So here's the plan of action. This is the glow driver, which allows me to start the glow engine without having to hook up any power to the glow plug, because you use the glow driver for that. Everything's predicated on your throttle setting, which you can precisely set the way you want it. So for example, if you want the glow driver to come on anytime the throttle is 50% or less, or 40, 30, whatever you ultimately like, the glow driver comes on. So obviously when you're starting it, you're going to be at low idle, so it lights up the glow plug, and you just basically prime and flip the prop in, you're good to go. And obviously when you're flying it, the glow driver would, for the most part, not be on. But the minute you start to throttle back, such as on the approach or coming out of a loop, anytime you go to idle, that way the glow driver is eliminated, and it gives you a much lower, smoother idle, and also the reliability that when you ram the throttle up, the engine is going to respond very nicely. So anyways, this glow driver is going to be under the floor of that fuel tank. And what it comes with is a charging plug, which will be located at a convenient spot in the airplane. And this is a grounding wire, which will be attached to the engine. This is the wire to the glow plug. Everything is routed through there. And these 2 wires basically end up on this plug, and it plugs into here. And I've made it the hole such that, I can easily route it through there. I'll also be putting cylinder temperature on this engine. I do that pretty well to all my big glow engines. And so everything can conveniently route through there, and the fuel lines as well. So this is the fueling valve I use, and one port goes to the throttle, and the other port simply goes to the fuel tank. So when you insert the little refueling piece, which is this here, and So this is part of your refueling system. And then when you go to refuel, you just simply push this in, and there's a valve in here. So as you're, I use an electric fuel pump, and as you're fueling it, it cuts off the flow to the throttle, so you don't end up flooding your engine, and reroutes the fuel to the fuel tank. And I use these quite often. I really like it. They work well for me. And the cowling is about so round, as you saw. And so what I'm going to do is, as you can see in the picture, I've done it before where it's hidden just behind the cowling. So it's probably going to be somewhere here, and then I can conveniently just refuel the airplane. You don't even see it. Everything is hidden. So I kind of like that. So that's the way that's going to be set up. So that's going to be good. I'm going to have to come up with a method of securing the fuel tank. Probably use Velcro. We'll see. Yeah, so it's coming together. This glow driver, by the way, is made by McDaniel RC. I have a number of airplanes that use them, and I'm really pleased with it. It's got a built-in battery, everything. It's electronically controlled, works really well. Okay, so we have a plan of action. The other thing it has here is a little red light, which obviously you put in a convenient spot. So whenever that red light is on, your glow driver is being powered. So really good system. And so we got the holes drilled. We know where the fuel line is going to come through and all the wires. That'll be epoxy resin. And yeah, we're good to go. So once I come up with the proper way of securing that, I'll be closing this up, building the top part up. The other thing I've done is I built a cockpit module, and it's very light. And since I've decided to put a full cockpit in, and it will mount from underneath, basically like this, and there'll be some tabs inside, and I'll be able to remove and install the cockpit as required to give me access to the fuel tank system and any other wires that are coming from underneath the fuel tank floor. And I left enough space just under that cockpit floor to allow any wires to run there. Now, in a situation like this, and particularly because I'm trying to maximize the full width of the cockpit, there will also be provisions made for the pilot's feet to extend, forward. And now the question of the throttle servo, this is going to be completely sealed off, so it's not like you're going to have any access up here. So, you would think, well, I'll put the throttle servo back here and just run a flexible push rod up to the engine, and that is definitely doable. However, I was really focused on trying to keep as much as I can forward of the CG. And fortunately, again, because of this compartment that we incorporated under the airplane, I've installed the throttle servo here. I have easy access to it. I still have plenty of room to put the glow driver in and batteries, and it's all been hooked up and tested, so we're good to go. So really, as far as the engine installation, there's, aside from some electronics, and that's already been pre-planned, is taken care of. And any wires that have to come out, and as it was designed for this opening to allow them to come under here. And the rest of the flight servos for the tail section will be mounted somewhere here. So it's good. Even that equipment will be relatively close to the CG. So that's where I'm at with the fuselage for now. The next step is to close this up with the same sheeting as we see here. And then because the Endecker has a rounded front, I will then build a rib superstructure and then sheet that, and that'll be, all completed. And really then, for the most part, the fuselage is done except for, obviously cockpit and windshields. I also fabricated a cowling, and I have some video coverage on how this was made, uh, and I'll be taking the foam out, and it's very, very strong, at least for now. And the whole idea of making this cowling the size I did, once the superstructure's on and all that, we'll see what it looks like. I was really bent on not cutting the cowling open to expose the engine. And now, you know, the end decker, the bottom of the cowling is actually completely opened. So, you know, one could say, well, you know, if I were to mount this inverted, and then I would have been able to use a smaller diameter cowling. But I'm personally not a big fan, particularly a big engine like this, to mount it inverted. It can be problematic in starting. The fuel then collects, you know, if you prime too much, and the fuel collects then, you know, in the cylinder, you can get some pretty bad kickbacks, and you can even lock it up. Uh, so I really frowned on it. By mounting it this way, or if you mounted it upright, um, you eliminate the risk of that. And you know, my experience when it's mounted like this, starting is just a dream. It usually starts the first flip, or you know, maybe two flips, but it's a great starting engine. And the other reason I went sideways is the type of exhaust system that I use for it. So that's the next few steps. And now the basic sweet and low, as per kit design, just has the engine fully exposed, which is typical of the other variants as well, such as the ugly stick and some other similar types. They just have the engine hanging out front, which is perfectly fine. However, as I mentioned in other videos, I'm just changing the look a little bit. So I made this cowling out of epoxy resin and fiberglass cloth. And the nice thing about making your own cowling, it's, you know, basically custom made, so it can be to any size, and more times than not, it'll be stronger than even the ones you buy, and it's definitely cheaper as well. And like this cowling is very strong. I Now, in terms of mounting a cowling, there are many different ways of doing it. It depends on the aircraft design and the type of cowling, but this is a relatively common way of doing it. It serves more than one purpose. By having this ring within the cowling, it just gives it more of a rigid effect to it, and it makes it very easy to install. I personally try to avoid mounting a cowling by using the fasteners, typically bolts. Some people use screws into wood. Uh, I normally don't like to do that, particularly for gas engines which vibrate a lot. Um, and I like the cleaner look by, you know, the bolts are coming from behind. You know, for most part, you can't see them, and gives that nice clean look. However, I have, in saying that, I have made designs where I did, you know, attach bolts, but I took many extra precautions to avoid any fatigue, cracks, or enlarging of the holes. However, that being said, this is a very, you know, good way of doing it. Now, when I installed this ring, when I first put it in and got it exactly positioned, I used CA glue to uh, basically attach it so it doesn't move. And then I went with fiberglass cloth about 1.25 inches wide, and I went from behind, and it was fiberglassed in. So it's extremely strong. Um, Actually, this whole cowling is very, very strong cowling. For those that are interested in attempting to make your own cowling, and like I said, it's not that difficult. And I have a separate video on that, and I'll provide the link for that in the descriptions. So uh, there's blind nuts installed. Now, typically 4 would easily do it. I happen to put 8, and which, you know, it's probably overkill, but I'll tell you, when you attach it, it's on there. So it just simply goes over like this, and basically just helps if the airplane was on the landing gear. There, so it just fits in like that, And then from behind, I use 440 bolts, and you simply attach it from here. So very easy, easy to take off and on for maintenance purposes. And I particularly uh, made the cowling because I didn't want the engine to be exposed. Now, more times than not, very common that you will have to cut an opening to allow the engine cylinder to protrude out because of the airplane design and the size of the cowling, which also accommodates obviously the cooling of the cylinder and the cylinder head. Now, in terms of cooling, this particular ring that was attached to the firewall, it does have an opening back here. And the other thing this ring does is it allows me to control the airflow within the cowling. So I'm forcing a good portion of the air to travel over the cylinders and exit out the back here. And uh, in future videos, I'll talk more about managing the cooling within a cowling because it can be quite critical, and there are some basic rules to follow. Now, I do have to still cut openings within the cowling to accommodate the muffler, which I've ordered, and I'm just waiting for it to arrive, and then I'll size everything up and make the openings for the cowling. And if I go fully Endecker design, which is a World War I airplane. Now, the Endecker had a good portion of the bottom of the cowling is completely open. So ultimately, if I go that route, then I'll have to, modify this cowling. But for now, I have it at this stage. Now, for those that are new to building, and in terms of installing blind nuts, now blind nuts are used very much in model building. Anytime you need to attach something, they're very convenient. I use them a lot because I just don't want to fiddle around with nuts behind or anything like that. It's just so convenient. You pop this on, couple screws, you just put it in and easy, very easy. Now, the other holes you see there is to accommodate, I use these fueling valves. And so they'll basically end up going through actually this portion here. They'll be attached like this, and I'll be able to refuel the airplane from behind. So, that'll be basically bolted like that, and then it'll come through the hole. I'll have to make some extra provisions. So that just allows me to hide the fueling valve and also very conveniently just go from behind and refuel it. And also a slightly different change with the sweet low, especially not having a cowling. It's just flat here, and but basically that's been all closed up as per kit design. However, I put this structure on top, and then it'll be sheeted, and this here gives this a kind of a little bit of a round effect, and just gives it a different look. And then of course there'll be an instrument panel on the back side there. Now, if you haven't done blind nuts before, just a quick little tip is, this is what a blind nut looks like. I'll give you another shot here on the side, a little closer look. But there's basically like a shank in there with threads, and then it has typically 3 barbs. And as you tighten this up from underneath, you're going to actually pull this right into the wood. So those barbs are going to penetrate the wood, prevents the blind nut from turning, and holds it on as well. Now, when you drill the hole, because that little shank in there, that entire thing has to recess into the wood, the hole has to be slightly bigger than what you would normally use just for the 440 bolt. And you can see how actually the blind nut is right there. Now, you need typically a minimum 1/8 of an inch wood and to take on the whole size of the blind nut. And when all you do is put your bolt through the hole, attach the blind nut, and then start tightening it. Now, I recommend putting a washer on it. And the reason is, as you start tightening it and pulling that blind nut into the wood, if you just use the head of the bolt the way it is, quite often as you're tightening it, it'll actually start to penetrate the wood and it leaves like a mark there. If you want to avoid that, just simply put a washer on it so that distributes the stresses as you're tightening it and you won't get it penetrating the wood in any way. And because this is just a light ply. So anyways, that's where we're at with the installation for now. And I'll show you further progress as we move on. Now I'm going to put this sheeting on here, and it's 1/8 of an inch thick, so it's kind of hard to bend. And so what I do is I'm going to put a bit of a curve already into it. And what I do is I simply take, this happens to be Glass and Shine, a higher ammonia-based type product would be better, or ammonia mixed with a bit of water. And I just give it a light spray and let it soak in there just a few minutes. And I wipe away the excess, and then I bend it basically to the curve that I want. So that's the curve I want. So I'm just going to go a little bit beyond that because it will spring back a bit. And now I'm just going to heat it up. So basically what I'm going to do is evaporate it, but I'm going to keep holding that curved shape in there. And that's just going to make it easier for me to mount it on there. So you can see now we actually put a bit of a curve in it. So that's actually pretty darn close. And that, now it's very little stress to glue that on. So you can see the curve in it. It's just a quick and easy way of doing it. There's a lot of different ways to pre-shape balsa wood, depending on the how much of a curve you need in it. Sometimes I've even made styrofoam shaped molds, and especially if it was bigger pieces, and I basically pinned it down and then soaked it in ammonia or you know, like some kind of a glass cleaner. A product that contains ammonia helps, and then I pin it and let it dry overnight. And especially if you need more complex, tighter curves. But since I only had to kind of go a slight curve here, it just makes it so much easier to glue it on. You know, you could pin it all down in that, but I'm basically going to epoxy it on with 5-minute epoxy. Just hold it there, and it'll be done. So anyways, just a little trick I use. This is, it's not a blow dryer, it's a heat gun, so it gets pretty hot. And just make sure you basically remove all the moisture from it. So we've got the top glued on. That turned out nice. And the backing of the instrument panel is in place, and the cockpit side combing panels are there, and so the cockpit's there. And of course there'll be the instrument panel itself, which will come here and actually go a little bit down in the cockpit. And so that really takes care of quite a bit. Eventually the whole fuselage is going to get a 2-ounce fiberglass cloth and epoxy resin. So then everything will be, you know, basically filled and smoothed right out. So I think I'm almost at the point where I'll probably make the tabs that hold the cockpit module in place. And once that's done, I'm getting to the point where I'm going to start preparing to build the wings. Now the cockpit module has been secured with a tab system, and it's solidly in there. Won't be able to move around with vibration, and it's very easy to take in and out. And I'll show you how that's done. And the similar system can be used on many aircraft should you have to have that requirement to be able to take the cockpit out to give you access to other areas. And the way it works is there's two 440 bolts right here, two of them. Again, they're just held in there with blind nuts, so it's very easy. And then there's a tab here, and to remove it, simply loosen these two bolts, and it comes out like that. Very, very easy. And there we go. Now that gives me total access to the fuel tank should I have to remove it and do any kind of maintenance. And to put it back in, simply drop it in and place it in there and secured with the two bolts. So that's all done, and there's not really much more to do on it. I'm glad that's out of the way, and we'll move on to the next project. I just want to mention one more little aspect about the way this tab system was constructed. Material choices are always important in whatever aspect of construction it is within a model. So in this tab system, this happens to be basswood. I mean, you could use other materials too, anything but balsa wood. Because you need the durability, balsa wood being a softer wood. And in saying that about balsa wood, even this little base here, this happens to be 1/64 plywood. And because if you didn't have, for example, this plywood base, over time the balsa wood would actually wear out, and you would lose the effectiveness of the tab keeping this snug. And so, I thought I would just mention that, not that you leave something like that out if you construct this kind of a tab system, something to bear in mind. So in saying all that, also as for the instrument panel, I made a template of it. That's going to fit in there. And so, the whole instrument panel, it does even, as I mentioned before, it does go down inside a little bit. But that's forthcoming when I actually do the construction of the cockpit, which is going to be a whole separate series on how to go step by step, trying to make it look as realistic as possible. So if you like the video, please select like and subscribe. If you have any comments or questions, like always, I welcome them. Thank you for watching, and we'll see you soon.